This video covers Module 8, Part 5, where we're going to look at some formulas and further applications of quadratic functions. So please make sure you're completing your guided notes as you follow along. One thing we've done in this class is practice solving for a given variable. And now that we know how to work with exponents and square roots, we can solve more complicated formulas for a specific variable. So for example, if I have a equals pi r squared and I want to solve that for r, my goal is to get r all by itself. So the first thing I want to do is I want to divide both sides by pi. Pi is a real number, it's about 3.14, and that would allow me to get my r squared by itself. Well, how do I get it fully by itself? Get rid of that exponent? Well, I have to take the square root of both sides. And remember, when we take the square root, we have to take plus or minus the square root. So plus or minus a over pi is going to be our r squared. And if we think about it a little further, the square would go away. And if we think about it a little further, we know that radius r, this is the area of a circle, can only be positive, so we could ignore the plus or minus. It's really just only going to be plus. So that's how we solved problem 1. For problem 2, I'm going to have s equals 30 square root of a over p. So I need to solve this for a. The first thing I'm going to have to do is divide both sides by 30. I need to get that 30 out of the way. So I have s over 30 equals the square root of a over p. And in order to get rid of the square root, I need to square both sides. So I'm going to go ahead, square both sides. So I get s squared over 30 squared is a over p. And if I multiply both sides by p, that's going to get my a all by itself. So I have a equals s squared p over 30 squared. My last example, I'm going to solve this equation. That's 2t squared minus 5t plus k equals 0. I'm going to solve this for t. And we're going to do that by using the quadratic formula. So let me pick up a new screen. How about this? So I had t squared minus 5t plus k equals 0. This is a quadratic formula, right? It's of the correct form. So my a is 2, my b is negative 5, and my c is k. I don't know what k is, but I can still plug that in to solve for our t. Normally we would have x be our variable, but this time it's going to be t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is our quadratic formula. So t equals negative 5 plus or minus the square root of negative 5 squared minus 4 times 2 times k all over 2 times 2. So t is 5 plus or minus the square root of 25 minus 8k all over 4. And I cannot simplify this any further. This would be our final answer. So let's start doing some word problems that involve working with square roots and involve working with quadratics. So a ladder is leaning against a house. This is supposed to be that house. And the distance from the bottom of the ladder to the house is 5 feet. That's this distance right here. The distance from the top of the ladder to the ground is 1 foot less than the length of the ladder. How long is the ladder? So we need to define some variables. I'm going to have that my ladder is x. And maybe I write that in such a way so that it doesn't look like a T. And if I know the distance from the top of the ladder to the ground is 1 foot less than the length of the ladder, I know that this is x minus 1, this distance right here. Now we can use the Pythagorean theorem, which says a squared plus b squared equals c squared, where C is the long side, which we call the hypotenuse. Which I totally did not spell right, but it's called the hypotenuse. So we're going to use this information to solve this problem. So I said this was x minus 1, and this is 5. And I know that a squared plus b squared equals c squared. So I'm going to have x minus 1 squared plus 5 squared. We'll let this be a and this be b, equals x squared, or c squared. We are substituting in our values into the Pythagorean theorem. X minus 1 squared, I'm going to FOIL this, gives me x minus 2x, x squared minus 2x plus 1 plus 25 equals x squared. Now I need to combine like terms. I subtract my x squareds. I get negative 2x plus 26 is 0. I can move the 26 to the other side, or I can move the x, it's up to you. I get negative 2x is negative 26, so my x is going to be 13. The length of the ladder is 13 feet. That's our final answer. Example 2 is an example where we're solving for an area. So a rectangular reflecting pool in the park is 20 feet wide and 40 feet long. The gardener wants to plant a strip of grass of uniform width around the edge of the pool. She has enough seed to cover 700 feet squared. How wide will the grass strip be? So the first thing I want to do is I need to draw a picture. So I've got a park. It is 40 feet by 20 feet. And I'm going to have a perimeter that's equidistant around the edge. How wide is this perimeter? I don't know. If I don't know something, having x be our unknown is a great idea. So I just kind of label my x's. So now the perimeter of my rectangle is 20 feet plus 2x by 40 feet plus 2x. That's the perimeter of my big circle. That's how I'd calculate the area. The area of my big rectangle is 20 plus 2x times 40 plus 2x. And I know that the inside area is 20 times 40. So if I take the area of my whole rectangle and I subtract the inside, I'm left with just that band. And that band has to be 700 feet squared. Now I can go ahead and solve this. I have to distribute 20 times 40, that's 800 plus 40x plus 80x plus 4x squared minus 800 is 700. And I need to combine like terms. Well, my 800 minus 800, that cancels out. I've got 4x squared plus 120x minus 700 equals 0. And then I can solve this quadratic by completing the square, by factoring, using the quadratic formula. I'm going to factor. So I'm going to take 4 times x squared plus 30x minus 175, because I could factor out the greatest common factor. So now that I've removed our greatest common factor, my leading coefficient is a 1. So I can solve this by finding the factors of a, c that add up to b. AC is negative 175, b is 30. What are the factors of negative 175 that add up to 30? Well, that's going to be negative 35, positive 35 times a negative 5, right? Positive 35 times negative 5 is negative 175, and those add up to 30. So I have 4 times x plus 35 times x minus 5 is 0. So I set these factors equal to 0. I have x plus 35 is 0, x minus 5 is 0. So I get x is negative 35 and x is 5. Now we're trying to find and plant a strip of uniform grass, and we need to determine the width. Can I have a negative width? No, that's our extraneous solution. So our real answer is going to be 5. This grass strip will be 5 feet wide. Example 3, I have a ball that is projected upward from the ground. And if you think about throwing a ball, it kind of forms an arc, much like a parabola. Its distance in feet from the ground is s of t is negative 16t squared plus 64t. We could think of it as d of t, like the distance. At what times will the ball be 32 feet from the ground? So when it's 32 feet, as long as it's not like right at our maximum, we're going to get 2 possible t values or x values for our time. So I know I want my distance to be 32. So I'm going to take 32 equals negative 16 t squared minus 64 t, and I'm going to move everything to the left, because if I do that, then my coefficients are all going to be positive, which just makes my life somewhat easier. So I've got 16t squared. Now my leading coefficient is positive, which is what I wanted, minus 64t equals plus 32 equals 0. Sorry, I'm recording this while so many people are still in the office. It's a little distracting. So next I could factor out a 16, or I could divide everything by 16. That'd give me t squared minus 4t plus 2 is 0. Are there any factors of t AC that add up to b here? Are there any factors of 2 that add up to negative 4? No. So let's use the quadratic formula. So t is going to be, let me go ahead and label my ABCs. A is 1, B is negative 4, and C is 2. T is negative b plus or minus the square root of b squared minus 4ac all over 2a. That means t is going to be a positive 4 plus or minus the square root of 16 minus 8 over 2. T is 4 plus or minus the square root of 8 over 2. That's going to give me 4 plus 2 root 2 over 2. T is 2 plus or minus the square root of 2. And if I plug that into my calculator, I've got 2 minus the square root of 2, 2 plus the square root of 2. That would give me my 2 t values. T is 0.59 seconds, and t is 3.41 seconds. Those are my 2 times when our ball will be 32 feet from the ground. So we have 2 more examples. So example 4 is enclosing the most area. This is an example of a problem where we're trying to maximize the area. And when I think about parabolas that have a negative leading coefficient, that are sad parabolas, those have a maximum point. So a farmer has 2,000 meters of fencing and wants to enclose a rectangular plot that borders on a river. What is the largest area that can be enclosed? So let's think about this. So I've got my river and I've got my fence. Let's let this be our unknown. So x, and I've only got 2,000 meters, so I've got 2,000 minus 2x is what's left on our long side. So my area in terms of x is going to be x times 2,000 minus 2x, because if I want to find the area of a rectangle, I take my length times my width. So I'm going to take my x times my 2,000 minus 2x. that gives me a of x is 2000 x minus 2x squared. Maybe I rewrite this so I have a of x equals negative 2x squared plus 2000x. And I can try and find the vertex. So h is negative b over 2a. So I have negative 2000 over 2 times negative 2. That's negative 2000 over negative 4. So my answer is going to be 500. And then I need to substitute that in. So I'm going to have to find my maximum area, which would be our a of x. So I have a of 500 equals negative 2 times 500 squared plus 2000 times 500. So a of 500 equals negative 2 times 5,000 squared. That gives me negative 500,000 plus 2,000 times 500. So plus 100, not 100,000, 1 million. So the maximum area would be 500,000 meters squared. And that would be when my x is 500. So then this side would be 2,000 minus 2 times 500. So that'd be 1,000. Be 500 by 100, 500 by 1,000, which gives me 500,000 meters squared. For our last example, we have a suspension bridge, and its weight is evenly distributed among its length, and it has identical towers that extend 75 meters above the road's surface and are 400 meters apart. The cables are parabolic in shape, so they're going to form a parabola. And the cables touch the road surface at the center of the bridge. We need to find the height of the cables at a point 100 meters from the center. So let's draw a picture. Here's my road. I have 2 towers that are 75 meters tall. What connects them is a parabolic shape that touches the road in the center. So let's let this be our vertex 0, 0. And these are 400 meters apart. So we'll let this be 200 meters. And this is also 200 meters, but we'll let it be like negative 200. So I've got negative 200 times 70 by 75. And this one, the point of this would be 200 by 75. So what I've kind of done here poorly is set up an XY plane. So I'm choosing where my parabola touches the ground to be the center, our origin 0, 0. And as my towers are 400 meters apart, I know that would divide the 400 in half, which would give me 200 meters here. And since this is the left side to be negative, and 200 meters here, so the right side of this would be positive. And then they're 75 tall. So this ordered pair right here would be 2,000, 75, and this would be negative 200, 75. I said 2,000, I meant 200. Apologies. So I'm given here my vertex, which is 0, 0 of this parabola, and a point on my parabola. Let's choose this positive one. And I can take my vertex form to find my a of this parabola. So I have f of x, that's my y, so 75 is a times 0, my x, which would be 200, minus 0 squared plus 0. So I plugged in my h and my k, which were 0, 0. Our vertex is always hk. And then I plugged in my X value and my Y value of 75. And then I would solve this. So I have 75 is A times 200 squared. 75 is 400A. So A is 75 divided by 400, which is 0.001875. So f of x would be 0.001875 times x squared, because my vertex is 0 and my vertex, my h is 0, my k is 0. I'm not changing this parabola at all. All I've done is change its shape by putting a fraction out front. I've made it wider than our standard parabola. So if I want to know the height, let's pick another color. Ooh, what's that? At 100 meters, what I'm going to do is I'm going to substitute 100 meters in for x. So I'm going to have f of 100 is 0.00185 times 100 squared, which would give me 18.75 meters. So the height of the cables at 100 meters would be 18.75 meters.